Hello everybody, this is module 10, the metals module. This is monster paper 4 and it is question 3. So group 1 metals are very reactive, yes they are. Transition elements are also metals, but they are less reactive than group 1 metals. So you see this and you're going to know straight away and they're going to ask you to compare the two. State 2 physical properties of group 1 metals which are similar to those of transition metals. So here you can list any one of the common properties of all metals. So the first one would be something like they are shiny, or another word would be lustrous. I do like the word lustrous. They are good conductors of heat. Now, you could use it as just good conductors, but usually in questions like this, it's a really, really easy mark because you can have good conductors of heat, and a second mark is for good conductors of electricity. So already we've got 3 there that we could choose from. You could also have sonorous. So, of course, you could have had all of these, but you're only going to pick 2. You're not going to write more because remember, in the exam, if you write 2 that are great and then you write a third thing that is wrong, then you are going to negate your previous marks. So please make sure that you only pick 2. Examiners know when you're hedging your bets and trying to write 3 things because you think one of them might be wrong, and they mark you down for it. So pick 2 and stick to it. Also, don't forget that a lot of students do not read the question and they they don't notice that it says physical properties. Remember, the difference between a physical property and a chemical property is that if you can just observe without doing a chemical reaction or measure without doing a chemical reaction, it must be a physical property. But if you need to actually change the chemical nature of the reactants and turn them into something else, a new product, to find it out, then it must be a chemical reaction. So, for example, variable oxidation states would be a chemical property because you couldn't test for variable oxidation states unless you did a chemical reaction. Whereas you can just look if something is shiny and lustrous, or you can just tap it to see if it's sonorous. You don't need to change the metal in any way. Same with good conductors of heat and electricity. We're not changing the metal, we're just hooking it up to a power source and seeing if it conducts the electricity, or hooking it up to a heat source and seeing if it conducts the heat. Describe 2 ways in which the physical properties of the group 1 metals are different from those of the transition metals. So it's now looking at how are they different. We've looked at how they're the same. How are they different? Well, there's 2 main questions. We say group 1 are less dense than the transition metals. But you don't need to write than the transition metals because it's already told you in the question, right? And the next one is group 1 have lower melting and boiling points. So you'll notice here that I am using comparative words because this is a comparative question. If you just put less dense or lower melting and boiling points, how does the examiner know whether you think transition metals have a lower boiling point or the group 1 metals have a lower boiling point? So you must be really, really careful here that you are stating which one is which. And it doesn't matter which way round you do it. You can say group 1 are less dense and group 1 have lower melting and boiling points, or you could say transition metals are denser and transition metals have higher melting and boiling points, but you must quantify that so that your examiner has no worries about which one you are talking about. So be really careful with that one. When group 1 metals are added to water, they fizz and an alkaline solution forms. So we need to remember that any metal plus water makes a metal hydroxide plus hydrogen gas. So that's a general equation that you just need to remember because it will definitely come out. So name the gas given off. Well, of course, it's hydrogen. Notice that it says name. It doesn't say give the symbol. It says name. Identify the ion present in the solution that makes the solution alkaline. Well, all alkaline things contain OH minus ions. All acidic things contain H plus ions. Write the chemical equation for the reaction between sodium and water. Notice how it has the word chemical equation. That means it's looking for symbols. If it wanted a word equation, it would have said word equation. So now it's looking for symbols. So sodium plus water. We use our periodic table if we're not sure, but sodium is Na. Then we're adding H2O because metal plus water. Then we make a metal hydroxide, so sodium hydroxide and hydrogen gas. And then we can see, let's check that we've got the right amount of atoms on either side. So one sodium. We've got two hydrogens here, but we've got three hydrogens here. So we now need to sort out our multiples here. Well, the most that we can do is turn this into 4. Well, how do we turn this into 4? Well, we need to turn that into 4. So now we've got 2 lots of H here, and we've got 2 lots of H here. We've got 4 on this side. We've also got 2 times 2 here, so that's 4. But now we've altered our sodiums here. We've got 2 sodiums, so we need to add another sodium there. Now our equation is balanced. A lot of students struggle with knowing how to write this chemical equation. Remember that if something is in group 1, like sodium, it has a 1 plus charge when it's an ion. We know our compound ions. You must know those 6 compound ions. So we must remember that OH is a 1 minus as well. And so if we've got plus 1 and minus 1, we need to balance each other out. So we know we've got a 1-to-1 ratio. So we are just a straightforward NaOH. Okay, if it was a group 2 metal, then of course the ratio would be different. Let's say it was calcium. We would have calcium as a 2 plus, and we would have OH as a 1 minus. So we would react in a 1-to-2 ratio. Therefore, we would have to have calcium, and then we would need to put our hydroxide in brackets and say we've got 2 of them to balance them out, because we need 2 1 minus to balance out 1 2 plus. Hopefully that makes sense. But of course, this isn't calcium. We got distracted, Mrs. Baker. Stop getting distracted. It is just sodium. It's nice and easy peasy lemon squeezy. Okay. Question 3 continued. When the transition element iron is added to the water, the iron goes rusty. It rusts. When an iron object is coated with a layer of zinc, rusting is prevented. Name the process of coating iron objects with a layer of zinc. That is, of course, galvanizing. Explain how completely coating an iron object with a layer of zinc prevents rusting. Well, of course, if we cover the iron with zinc, we're actually stopping the oxygen and the water from getting to the metal. So we're going to say zinc provides a covering which prevents oxygen and water from touching the iron. And if the oxygen and water can't touch the iron, then there can't be a chemical reaction. It's like providing a barrier. So maybe instead of covering, barrier is probably a better word. Rusting on iron ships can be prevented by attaching zinc blocks to the hull of the ship. Explain how this prevents rusting. Now, this is something called sacrificial protection. And if you've got your boat, this is my wonderful drawing of a boat. There you go. I'll even put a sail on for you. There you go. You're welcome. If on our boat, it's in the water all the time, so it's got water bobbing all over it all of the time, what we will do is put these blocks of zinc on the side. Now, the zinc is more reactive than the iron which is in the boat, which the boat is made out of. And so the zinc will sacrifice itself. Because it's more reactive, the oxygen and the water is going to react with the zinc in preference, because it's easier, it's going to react in preference than the iron. So the zinc is going to, these zinc blocks are just going to sacrifice themselves, and the iron is going to remain unoxidized. So it's a 2-mark question. So the first thing we're going to have to obviously point out to the examiner is that we know that zinc is more reactive than iron. And then we are going to say zinc will oxidize in preference to the iron. And you'll get the mark for both of those points. So we've got 2 bullet points because it's a 2-mark question. That was question 3. Hopefully it was helpful.